Hello, abstract algebra students. We will now look at the closure property for R under double multiplication. And as it turns out, R is closed under double multiplication, and the proof is very similar to the proof that R is closed under double addition. So our claim is that the set of real numbers R is closed under double multiplication. Double multiplication being the operation A star B equals 2AB. Now, what we want to show here is the definition of closed applied to the set R under the operation double multiplication. So we want to show for every pair of elements A and B, if both A is a member of the reals and B is a member of the reals, then A star B, given by the formula for double multiplication, is also a member of the reals. Okay. To prove this, we have a quantified if-then statement that we are trying to prove. Because it begins with a for all quantifier, our proof begins by letting A and B be given. Because we have an if-then statement that we're trying to prove, we assume the if part and we try to prove the then part. Assume that both A is a member of R and B is a member of R. Now, we want to show that A star B is a member of R. And if I don't see how to do this right away, again, I can take out a piece of scrap paper and work backwards from where I want to end up. I want to end up with A star B is in R. Now, I know by the definition of double multiplication, I need to show that 2AB is in R. Well, I know that 2 is in R. So if I can get that AB is in R, I can use the fact that R is closed under multiplication to get that 2AB is in R. And then I can use the fact that A star B equals 2AB to get that A star B is in R. So the trick here is I need to get that AB is in R. However, I already know that both A is in R and B is in R. And I know from the bullseye that R is closed under ordinary multiplication. So I think I can write the proof now. Since we know that all of A is in R, B is in R, and R is closed under multiplication, it follows that AB is in R. Since we know that all of 2 is in R, AB is in R, and R is closed under multiplication, it follows that 2AB is in R. Therefore, Since we know that 2ab is an R, by definition of double multiplication, they conclude that A star B is a member of R. And that completes the proof. So we let AB be given because we had a for all statement. We assume that both A is an R and B is an R because that's the if part. And our goal in these closure proofs is to build up the expression for A star B being an R. So since we know that all of A is an R, B is an R, and R is closed under multiplication, it follows that A times B is an R. Since we know that 2 is an R, AB is an R, and R is closed under multiplication, it follows that 2AB is an R. Therefore, since we know that 2AB is an R, by definition of double multiplication, we may conclude that A star B is an R. Because, of course, double multiplication is A star B equals 2AB. That was the last proof for today. In the next video, I will wrap up this lecture.